So good morning. GSA has 370 million square feet of space across the United States. The shocking thing is we think that that is big, and sometimes we say we're the country's largest landlord, and I think that's roughly true for office space. But in terms of buildings, that's only 1/10 the number of buildings that the federal government owns, operates, and manages, because we have a few things that we don't take care of: the embassies, military bases, and the one I'm most grateful for, the U.S. prison system. But what we're doing, I think, in all of these cases is we're trying across the federal government to do precisely the things that we're going to be talking about today. And it's a bit of a daunting task. We have an inventory, in our case, that's averages 47 years old. We just did a half of a renovation on our headquarters building. The previous renovation was done in 1937. So you get the sense of, and it's a 1918 building, so you get the sense of exactly how much money we put back into infrastructure. This is, of course, a huge issue, not just for GSA, but for every state and local government, for towns and cities across the country, because we don't have a reinvestment mentality for things that already exist. We love shiny, bright new things, so we put a lot of focus on new buildings, but our focus really needs to be on the 80% of buildings that you see around you today, which are going to be the same ones that your kids see in 2050. And I think that's one of the things that the mayors of cities have begun to realize, and in many cases, the leadership in transparency and benchmarking has shifted from the federal government to city governments, not state governments. They sort of leapfrogged over states. I don't know of a single state that has statewide benchmarking requirements like anything remotely like what the district has here, the city of Atlanta, the city of New York, and so on and so forth. But I do want to talk about this in the context of the sort of three different looks. One is how we use data in GSA sort of on a micro level, and then sort of this mid-micro level at the portfolio level here. Secondly, I want to do examples of whole building retrofits. I have one example there. And finally, a fully occupied building with an energy savings performance contract that's pretty local. You can see it by looking out the metro window sometimes, actually, here. So what we've done, partly as a result of the Recovery Act in GSA, is we took a look across the entire portfolio, and we had, at the time, a few advanced meters in places where demand response made sense: Washington, D.C., and New York. And that was it, a few. We now have advanced meters in, and so this is the kind of data that we were dealing with, and this is based on monthly energy bills. And you can see we can go back all the way to pretty much certainly 1985 is all in the database. And we know every building in the inventory, what its energy consumption was with all 6 sources of energy that we track, and the energy use intensity, which we committed in 1985 to reduce by 30% by 2005. And we barely made it. We got to about 31.25% total reduction. Then the Energy Policy Act required us to drop 20%, or double the rate of decline, in the next 10 years. And then the president upped that to 30%. So we have just completed the 2005 to 2015 with a 30% reduction in energy use intensity. And this is at the same time that we are increasing the density of buildings. The startling fact about buildings, office buildings in the United States, is they're 50% empty during the working day. Part of that is because of the obvious. where you sit back in your offices is now empty because you're here. And if you just look at the way people work and the amount of mobility and so on, we've measured in over 230 locations that buildings are 50% empty. This causes a number of problems. First of all, it's a missed opportunity. Second of all, it is it gives you a distorted sense of what's actually happening in the building in terms of the energy needs of the building, because if you're pretty much all the energy modeling is based on 100% occupancy. All the fire code modeling is based on 100% occupancy, and we just don't experience that. So, but at the same time, and we've recognized that, and we're increasing the density of buildings across the federal government. For the first time in almost 45 years, actually since Lyndon Johnson was president, the actual total space occupied by the federal government is declining. Otherwise, it had gone up with very, very few exceptions every year over the whole time. And if you look at who was president when the government expanded the most, you get some very surprising things. But one of the great expansionist presidents of the 20th century was Ronald Reagan, which is not the reputation that you would understand from his legacy. The previous one was Richard Nixon, who ironically was the person who implemented the Great Society programs and expanded the federal government pretty dramatically. If you look around Washington, D.C., and look at the Department of Housing and Urban Development, the Department of Labor, the Department of HHS, and the Department of Education, all created in the Nixon administration. So it's an interesting sort of historical note. So that's the sort of the portfolio look. We took a strategy to advance metering to look at the 80%, it's really classic operation of the 80-20 rule. 190 buildings out of our inventory of owned buildings of 1,600 account for 80% of the energy consumption, electrical energy consumption, 75% of the energy consumption. We now, as a result of the Recovery Act, have advanced meter information on 80% of our total energy consumption. And by advanced meter, of course, I mean interval meters that are capturing the data every minute of the day and then storing it at 15-minute intervals for a while, and then greater intervals as we go further away. That information is extraordinarily useful on the local level. We found some very interesting things. One of the fun stories is in a certain construction site next to one of GSA's buildings. When we actually installed the advanced meters, we got some information about Saturday electrical consumption that seemed surprising to us until we discovered that the construction site had actually gone across the fence and tapped illegally into our power supply and was stealing our electricity. So we waited until 11 o'clock on Monday morning when the crews were just getting started, and we went out and disconnected the line and shut the construction site down. They really couldn't complain too much, but it's the power of that. We discovered in one of our sites that the contractor, we do 97% of our work through contracting for building services. The contractor didn't like the elaborate program of operations that we laid out with the setbacks different every single day of the week and so on, and thought that they could get away with fudging the matter. And so they didn't do anything, but they set back the building systems every day for an hour between midnight and 1 a.m. and thought that, you know, that setback would fool us. And actually with meter data once a month, it did fool us. But as soon as we got the hourly meter data, it's kind of like, are you guys crazy? Why even set it back for an hour at that point? You know, anyway. So you find out some real interesting stuff. But that's sort of the gross neglect kind of things. What you really can find out on a building data, and the other speakers will get into this in even more detail, is pretty extraordinary. So here you see a couple of charts that show the penetration of advanced meters across our inventory. We're working up there. We found, that we're required by law to get 75% of our electricity with advanced meters, also water, steam. But we found that this information is so useful that we're systematically going beyond that. I should also say that this is, these statistics are based on 1 meter for the building. We actually participated with the Department of Energy in a challenge to industry to get the cost of meters down so that we could really get to more ubiquitous sub-metering. We're a big proponent, along with Jason Hartke at the Department of Energy, at getting to sub-metering at the system and client level so that we can actually look at who's using what kind of energy during the day. It's something that has very strong commercial equivalence, and we're working now to ensure that we get a standardized energy conservation measure that the industry is willing to accept, and across the federal government we will accept, because the argument goes like this. The meter doesn't save energy, so you can't call it an energy conservation device. So you've got to couple the meter with doing something with the information. That seems pretty obvious to everybody in this room, but if you get a bunch of contracting weenies together, they will figure out a way to make life difficult and complicated. So yes, the meter itself doesn't actually save you energy. And in fact, if you put a meter in and don't do anything with the data, arguably it consumes a little bit of energy. But that's not the point. The point is you can find out what's going on in the building in ways that you had no idea of before you install the meter. We also, as you can see, have got a great progress on advanced metering with steam and gas. What we're working on, I think the most, however, is water at this stage of the game. We're a little bit behind the 8 ball on water. Part of the problem is really straightforward. Water is undervalued as a resource in this country. It's underpriced, and so it's really tough to get any building manager who's managing a budget excited about water conservation, unless, of course, the state tells you you can't use the water that you've been so used to using, which, by the way, is going to happen more and more frequently. If you want to get really depressed, take a look at some of the long-range forecasts by the science agencies of the federal government about where drought is going to crop up and with what kind of frequency, and you begin to wonder why people are building data centers in the middle of the desert. But look at the difference it actually makes in performance. Where we have advanced metering, we have a 21% reduction in EUI. Where we have monthly meters, we have a 3% reduction in EUI. This shows you pretty dramatically what happens when you have the data. You can achieve savings that you don't know, frankly, you don't know how to do in unmetered buildings. We also sort of step back for a minute. One of the issues that we all have is that buildings are more complicated than they were 40 years ago. The systems are more complicated, and we don't have a system of technical training in this country the way they do in some other countries, Germany, for example. Germany graduates 10 times the number of people with a degree in facilities management than we do in the U.S. 10 times. They're a country that is 1/10 the size of the United States in terms of number of buildings. So they basically have a 100-fold advantage just in the education. So we've got an educational deficit here, but we've also got an issue of cost. I mean, if you get a really excellent mechanical engineer, like we have several of in GSA, we have quite a few of them. If you give them one building, they get bored to tears. but if you give them a portfolio of buildings, all of a sudden they get excited. So one of the things that we've done is really tried to take advantage of this. So this was actually pioneered by our Fort Worth region. They realized that they could hire a couple of really good people and look over a portfolio of buildings and send the information out. It was sort of a crude, put-together system that required, individual analytics. It didn't have any of the software that you're going to hear about today, but it did let you know that this ability to get somebody who really understands systems and have a dialogue with the building operator can figure out what's going on. And in fact, it was in this region that they discovered the building operator who was just running the buildings 23 hours a day rather than 12 hours a day. So centralizing is doing that. We also looked at remote diagnostics. We happen to have done a competition. There are other, this is not a product endorsement. We happen to use First Fuel because they won the competitive contract, but there are other companies that can do this kind of remote diagnostics. It's particularly useful, and it's based on building characteristic data, all data that is readily available in any building manager's office or online, we hope, or plus the advanced metering data for a year. And you see here the comparison of what happened. So when we were a little skeptical, you can just read the meter data and figure out all the energy conservation that you need to do in the building. But we did a test. We said, you do your diagnostics, but we'll send one of our traditional energy audit teams out to do it. And what you see is that that we found more things by the remote method than we found on site. More things that we could do to improve the energy performance of the building. 60% of this stuff both teams found. 26% additional items found by the remote diagnostics, and 14% by on-site diagnostics. And that doesn't seem like it's a huge difference, the 26 versus 14%, until you realize that the cost of doing the remote diagnostics was 20% of the cost of sending out the team. So for us, we get 26%. We're missing that 14% there, but we get the 26% that the team wouldn't have done. So we're really ahead of the game already. Plus, we can do it 5 times more than we would be able to do it otherwise. And so our recommissioning and energy audit stuff is now being done entirely this way with First Fuel, and we've been very pleased with the results. This is not the be-all and end-all. It is your first touch diagnostics, and as I said, there's competition out there, and they're all getting better. We have also, and I don't hold this up as a IT success story because there's issues with the way the IT actually works, but it's a conceptual success story, which is get all of that data in a centralized cloud application of some sort so that you can analyze it at any portfolio size that you want. So we can look at it at nationwide trends, we can look at it by state, we can look at it by city. Anybody can get into the system and look at it. Now, don't say it's a great IT success story, as it's a whole bunch of things that are a little clunkily put together. We're in the process of rethinking, just because contracts expire and you get to rethink and technology improves, our approach to this. So anybody who's actually in this business should be watching FedBiz Ops, because there's going to be a big juicy contract from GSA one of these days. It's not out yet, so it's coming. I don't know exactly what the schedule is. And that's a good thing, because if I knew a little bit more, then I'd be able to say even less than I know now, just because of the procurement rules. It's how it works. But you can see the level of detail that you can get at here, and what this enables you to do is automatically program the system so that it will notice things and send alerts. Now, is that no work at all? Not at all. It is work. You have to think about building by building, how you want the building to operate, and you get sort of some standards in place. But we operate office buildings for the federal government. Most office buildings in the country operate pretty much the same way. People have certain patterns. The building manager knows the local stuff and can get in and make those adjustments. So you can actually do some master programming where you have types and scales of buildings. You know, we have a bunch of courthouses. They all pretty much operate on the same kind of schedule wherever they are in the country. We have some laboratories, but mostly we have vanilla office buildings, and they have characteristics. They have data rooms that you know you have to take care of. But you can do this, and this is really valuable for anybody on a portfolio scale. If you're just doing this on a building scale, it's actually pretty straightforward because you're listening to the tenants already, and you're already doing this, and it's just getting it in there so that the system is watching all of the time, reduces your labor costs, and gets you out of sort of trying to figure out what's going on in the building retrospectively and enabling to react forehand. GSA worked with the White House and others in industry to test green button technology. And the whole idea about green button is, you know, it's as simple as a button you push, you get your utility data down there. The deal was, can we develop a standard for data downloads from a utility? And the answer is yes. It's called the Green Button Standard. It was developed pretty quickly. It's been tested on extremely large utilities and small in multiple parts of the country. So if you are a recipient, you're in an area where you can get it, you can get the utility data directly and into your systems, which is an important double check there. GSA also believes in openness and transparency of data and the value of benchmarking in particular. So our data for our entire inventory is up on energy.data.gov, and it's there so that anybody can benchmark against those buildings. So energy.data.gov, it is not a site of great user friendliness. It is a site of great data friendliness. There's a lot of data up there. You do have to work to use it, but the fact is it's there. And people are developing apps that work off of that data. They're developing the ability to do benchmarking using that data, and that's why we put it up there. It costs us almost nothing to put our data up there because we don't have a great user interface. It's a data dump. But it's there and it's available for you to use, and I think it's an important resource, especially if you have a larger portfolio. So a couple of examples. I mentioned the GSA headquarters at 1800 F Street here in Washington, D.C. I said it was 1937 when they did the renovation. It was actually 1935, according to this slide. So bad memory, I guess. We did a modernization of this building with infill. Now, here's the interesting thing about this. $161 million from the Recovery Act. Now, we got much better energy performance, but if you do the return on investment of this kind of investment in a building based on energy performance alone, you do not get a sensible financial return on investment. You don't modernize a historic building like this for energy savings alone. What we did do, however, was we increased the density of this building from 2,300 people to 4,400 people, and it'll go to 6,000 people when the second half of the renovation is done. The lease cost savings are $24 million a year of avoided costs that we're not spending, and that's real leases that were here in the Washington area. It's one of the reasons that Crystal City is a little bit more vacant than it used to be. And those savings turn this investment into a 13-year simple payback, which for a whole building modernization is an extraordinary low number. One of the things that happened in the Recovery Act, and this is sort of a quirk of construction contracting, because one of the things project managers are taught from the very, very beginning is that there is no such thing as a good change order. And so we do a lot of things to avoid change orders, including not changing the specs. Now, this building had a a long history. It's GSA's headquarters building. Nobody in Congress thinks that GSA is the most important agency of the federal government, so money for doing our own headquarters is not readily forthcoming. Just to give you a sense of that, when I worked in the National Capital Region, I worked on the prospectus for modernizing this building. I left the National Capital Region in 1989, and I had already been working on the modernization of this building, which was started in 2009. So the problem was that we awarded the design in 1999. Now, for those of you who follow the Energy Code in ASHRAE 90.1, there was a big hiatus. There was one version in 1989 and another version in 1999. We, of course, put out the specs referencing the current version, 1989. And because change orders are bad, we didn't update it when ASHRAE came out with the new specs. So then we tootle around and we finally, ASHRAE 1989, then 2004, then 2009, several updates, almost 50% reduction in energy consumption requirements according to code. And we have this wonderful 100% design document finished in 2009, ready to go. It's shovel ready using the 1989 Energy Code. So, and it would have still done energy reduction, but we would have delivered, if we had followed those design documents, a brand new renovated building that operated at 50% higher energy consumption that our whole portfolio had already gotten down to. This was, by the way, a total energy dog when we started, almost 110,000 BTUs per square foot per year, which is above the office average in the United States and way above GSA's portfolio average of 67. So we did challenge them to do a little bit better, and they didn't do a lot better. They didn't do a little bit better. They did a lot better. Got it down to a 3 times as much energy savings as there were before, and really exploiting all of the technologies that we have for worker mobility. 80% of the people in the building don't have a fixed desk. They can book a desk for a week at a time if you want, but it's not there. Interestingly enough, we, except on one day of the week, Wednesday, we don't even approach 80% occupancy in the building, which was our goal. So we're still finding that people are more mobile than we expected. We increased our telework policies so that people could work more remotely. We haven't quite figured out how to get people to want to come in on Monday and Friday rather than Tuesday through Wednesday, so we have this beautiful bell-shaped curve. If you want a conference room, don't look for one at the last minute on Wednesday. They don't exist. We increased the meetings and conference rooms by 250% to facilitate this, and that turned out to be a big mistake. The right answer is 400%. And so that's what we're doing there. But I think that sort of the interesting thing about this is that the average, in the new part of the building, the average zone size is 6 people. So we get control of this building at an extraordinarily detailed level. And you can see the kind of spaces that are there. We've been fine-tuning the building, and I will tell you that there are 2 main reasons why this building really operates, and that is the building manager personally and the head engineer from the contractor who runs the building. Those 2 people are the reason why this building actually hums. I would also give a shout out to the systems integration that took place, because we have, we have Siemens and we have Honeywell and we have all different kinds of systems going on in the building, and Lutron and so on. They are all integrated in a way that the building manager can control it really expertly. So here's what the full renovation will be like when we get there. I'm going to really gloss over the Edith Green Wendell Wyatt building, except to say this, that all of this integrated design that enabled them to cut the energy consumption in this building by 75% and the water consumption by 80% was because during the renovation design, they used the energy model as a design decision-making tool. They did over 40 full-scale energy models as they were making design decisions. And if you start talking to the people who designed this facade on the west side that you see here in the left-hand picture, which are shading screens, they, you know, if you ask the architect, you know, how did you design your shading, the architect will tell you what the engineer says. It's not a shading system. It's an integral part of the mechanical system of the building, because that facade, fixed though it is, enables the mechanical system to be downsized in such a way that it can operate efficiently. And moving from a air-based system to a water-based system enabled us to save so much space from air ducts alone that it was the equivalent of adding an entire floor of extra space to the building. So that's, and again, an extraordinary benefit that you don't normally see in that kind of redesign. And, you know, a lot of light penetration and so on. The last specific example I want to give here is the new Carrollton Federal Building. You can see the stats, and I will sort of let you read them rather than me reading them to you. The amazing thing is it's a 1995 building. It's a relatively new building. It's not one of those schlock buildings that we put up in the 70s with the fond hope that it would be torn down by the 90s. This is a building that was built to last. It achieved, through an energy savings performance contract with not one penny of capital from GSA, a 62% overall energy reduction. There are 11,000 individually addressable and controllable LEDs that took the place, switched over to ground source heat pumps and geothermal wells, supplementing that, reduced the water consumption, added a solar canopy over the parking lot, which not only improves the electrical performance of the site, but also shelters the cars, which means that sort of an ancillary benefit is that they don't heat up as much as they would in the summer, which then uses more gas mileage and so on, because you're cranking the air conditioner for 10 minutes before you can even get in the car because they're so hot. Anyway, you get the idea. The point is you can do it. And again, it's all of these things working together in an integrated way so that you can downsize the chillers because you've worked on the insulation, because you've worked on the roof, because you've worked on all the other things that they go through, and the windows and all of that. So it's a question of looking at everything, putting everything on the table. And this thing has a positive payback currently projected in 22 years, which is pretty good when you consider that included entire roof replacement and solar installation as well as the heat recovery loops and everything else that you see on the slide here. So that's what we're trying to push with the energy savings companies, is you can do really great things. And again, fully occupied building with a data center in here, which of course you have to work with the tenants and make sure that you can do that, but changing data center technology coupled with data center operations is a huge opportunity in any buildings. And you can see the result. And again, very, very detailed energy modeling leading to decisions, leading to a new way of operating the building with this kind of detail there. So we have all of these data on gsa.gov/sustainability. There's a bunch of stuff actually up on the White House website, most of that doing with the Recovery Act. Energy.data.gov is linked up there as well. So thank you very much for all of that.